Namaskar. I welcome all of you to Degree Calculations 10th episode. Last time we were studying about making some developments of certain job. Job means this kind of one job. Last time I had indicated its plan, elevation, and other all details. Today I don't waste time. I didn't write its elevation and other details. I have just written 1180. That is the diaphragm here to here. I haven't indicated whether it is major diameter or minor diameter, but we can recognize it is medium diameter. It means it is coming in between major diameter and minor diameter. I don't waste time, so I didn't write major diameter or minor diameter. Last time I was writing about major diameter, it was 1000, 1200, 1180 plus 20 mm thickness. 10 mm thickness has to be added from here to here, and 10 mm thickness has to be added from here. So 1180 plus 10 mm from here to here, and 10 mm will be from here to here, then total 20 mm. And you know, last time I had told you its thickness is 20 mm. I didn't indicate it in proper way. I have just made rough sketch only. Its thickness is 20 mm, and it's this much of length is straight length. From here to here, there is no radius, that is 700 mm. And I had, in elevation, I had indicated its height, it was 2000. Today I didn't write elevation. Elevation means a front view, because we have to do a lot of pattern developments, so we shouldn't spoil time. But when you draw, you have to draw it with full scale, because you are studying. I am just teaching you only, so I have done this all with freehand sketches. So for making this kind of one my job with the height of 2000, we have to make this kind of development. We have studied about it last time. From here to here, it will have rolling. That length is 1853.5, and from here to here there shouldn't be rolling, and there will be straight portion. That is, its length is from here to here is 700. I have indicated it here, and its height is 2000. Its height is 2000. I didn't draw its front view. It means elevation I didn't draw. And so if we take this kind of one jobs, this kind of two jobs, we can roll, then we can tag this job, and we can make this kind of job from here to here. One plate will reach, and another plate will come from here to here. So one joint will be here, one joint will be here. These things can be tack welded. Afterwards we shall start welding. So it is its development. This kind of two jobs have to be made. I have told you about it, those all. So how much of length we have to take? Its height will be 2000, and from here to here 1853.5 plus 700. How much is 1853.5 plus 700? That is 2553.5. So if we make this kind of one development, it will have a length of 2553.5 and width of 2000. Then we can roll, and 700 portion should be kept straight. Then we will get this kind of one job. But what is the main problem means, last time I had told you, for welding purpose we have to give gap here. welding penetration. For welding penetration, we have to give gap here. According to different types of welding specification, it may be 4 mm, sometimes it may be 5 mm, sometimes it may be less than 4 mm, sometimes it may be more than 5 mm. But last time when I was teaching you for calculations, I used 4 mm. So now just think about 4 mm thickness. If we give 4 mm gap here and 4 mm gap here, what will happen when we take this kind of two jobs as a development? Its length is 2553.5 from here to here. We will roll it, afterwards we will keep it on one floor. From here to here, it will touch. Here to here, it will touch. There won't be any gap. So we have to give gap. That time, if we grind, if we gas cut, we will be losing time. We will be losing accuracy, finishing. Double work will be coming. It is rework. It shouldn't be happened. One good fabricator shouldn't do this kind of works. One good fabrication supervisor shouldn't do this kind of work. One good fabrication engineer shouldn't do this kind of work. So before taking this kind of pattern development, we have to decrease how much of mm we have to decrease. We are going to give 4 mm gap here. It means in this plate, in this area we have to give 2 mm gap, and in this plate here also we have to give 2 mm gap. Same way, in this plate, in this area we have to give 2 mm gap. Same method we have to follow here in this place also we have to give 2 mm. So in this area we have to give 2 mm gap, in this area we have to give 2 mm gap. Total 4 mm gap has reached there. Here also we will decrease 2 mm from this plate, 2 mm from this plate. Then here also we will get 4 mm gap. So how much of length we have to decrease from this plate? I am telling about this plate which is in this upper side. We have to remove 4 mm from there, because 2 mm we have to remove from here, 2 mm remove from here. So whatever measurement we have taken earlier, it was 2553.5. If we take this kind of one measurement, we won't get a penetration gap, welding penetration gap. So we have to decrease 4 mm from here. I have told you about it last episode, so I don't describe those all. 2553.5 minus 4 will be 2549.5. It is for welding gap. If we have to give proper welding gap, we have to give this much of length only. We have to take a length of 2549.5. But there is no need for us to decrease 4 mm from 2000. Why? In this job, it's a top side. There is no welding coming. And in this job's bottom side, there is no welding coming. It means if we make this kind of one development, we will roll it. It is its top side. From here to here, it is its top side. Its top side, no material is coming. According to our drawing, they haven't indicated that one job is not coming there. If it is coming there, we have to take bevel there, we have to take penetration gap there. So now there is no indication, so there is no welding coming here. So there is no need for us to remove 4 mm from here. Here also, bottom side also, there is no welding comes. So there is no need for us to remove 4 mm from there also. Only welding comes here. From here to here, welding comes. And here to here, in this area, welding comes. So in this length, we will have to decrease 4 mm. So it is for welding gap. Afterwards, I told you last time about some nozzles. What kind of nozzle we have to use for gas cutting. So many nozzles I told you. Finally, I told one nozzle is there. Its number is 116. You know the details of this all. 116 means 116 inch. 1 inches 1 inch has to be divided by 16. In that 16 portions, one portion has to be will be the diameter of this nozzle's center hole. This 116 means it is 116 inch. How to calculate 1/16 inch of 1 inches 1/16 inch we have to calculate. For that purpose we have to what we have to do, I told you those all. 1 inch is 25.4, or everything you know. Last time I had told you 25.4 into 1/16. Then we will get a measurement number 1.59. It is the diameter of the center hole in this nozzle. It will have a diameter of 1.59. I don't describe this all more because last time I had told you about it. So when we do gas cutting or plasma cutting, at least now just forget about plasma cutting. We can think about gas cutting. So when we do it, it's a center hole. Oxygen is coming through the center hole. Its diameter is 116 inch of 1 inch. It's 116 means 1.59 mm. 1.59 mm. This 1.59 mm will be going out from this material. That is the minimum. Minimum 1.59 mm will be going out. Sometimes its double also may be gone. It means 1.59 mm's double is 3.18. 116 inch means 1.59. This 116 inch means 1.59 into 2 is 3.18. So when we do gas cutting minimum this much of material will be lost. Minimum. Maximum this much of material will be lost. So we can take a proper measurement in between these two. This 1.59 is the measurement which we get 116 into 1. This 3.18 is 18 we get 116 into 2. 116 into 2 is 3.18 and 116 into 1 is 1.59. So in between what kind of measurement is coming? For that purpose we shouldn't multiply this 116 into 1 or 116 into 2. Instead of that, we have to multiply this 116 into 1.5. So in between what kind of measurement will come, that will be reached. So in between this 3.18 and this 1.59, 2.38 is coming. 2.38 means there is no need for us to get this much of accuracy. 2.38, we can remove this 8. If we remove 8, this 8 is bigger than 5, so the previous number has to be added with 1. So 2.38 will become 2.4 because we are removing this 8. That there is no need for us to get that much of accuracy. 2.38, from 2.38 we are removing 8. When we remove 8, it is bigger than 5. So we have to use 4 here, 2.4. So the proper gas cutting allowance is 2.4. It is very difficult to calculate 2.4 when we mark it in plate or sheet. So approximately 2.5 mm we can take. Gas cutting allowance is 2.5 mm. So what will happen? We have finally we recognized its welding. With welding gap, it has to have a length of 2549.5 into 2000. But when we cut it in the center, because just imagine this plate is this one. We are cutting this plate from a big plate. In this big plate, we have to cut so many plates. One plate is coming in its left side, another one is coming in right side, another one is coming this side here, and it's a corner side also. so many plates are coming. So this is our job. It is this 2549.5 into 2000 job is this one, center one. If it was only one plate in this big plate, we were able to cut in its outside. So direct measurement we can add 2549.5 into 2000, we can mark and we can cut if we were cutting it in its outside. But in this plate we can't cut it in its outside, because if we cut these plates outside, this is a job, another job, it's 2.5. Now our gas cutting allowance is 2.5. 2.5 mm will be lost from here. 2.5 from will be lost from this plates this side. 2.5 mm will be lost from this plates this side. 2.5 mm will be lost from this plates this side. And this plates 2.5 mm corner will be lost. This plates also same, corner will be lost. This plates and this plates also corner will be lost. So when we mark in a big plate and this big plate has been filled with a lot of markings, we have to really add gas cutting allowance. Means we shouldn't mark 2549.5. If we mark 2549.5 and we cut in its center, we will lose 2.5's half here and 2.5's half here. 2 halves of 2.5 has come. It means total 2.5 mm will be smaller, will become small measurement. So we have to add 2.5 with this measurement, 2549.5 plus 2549.5 plus 2.5 is 2552. 2549.5 plus gas cutting allowance is 2.5. We added it. It is 2552. If we mark 2552, then afterwards if we cut here, what will happen? 2.5's half will be lost from this plate. 2.5's half will be lost from this plate. Total 2.5's 2 halves. It means 2.5 will be lost. But after gas cutting, we will get proper measurement 2549.5. So we have to mark 2552. It is cut for cutting allowance. I have added 2.5 and it became 2552. Here it was 2000. From 2000 also we have to add 2.5. It has become 2000.